This video is on section 4.3, right triangle trigonometry. Here are the objectives that we will hope to accomplish in this video. We'll talk about acute angles, different trig identities, and then of course we'll have some applications. A lot of times when we are dealing with acute angles, or acute triangles really, the angle across from, the side across from the angle is referred to the opposite. The side closest to the angle is adjacent, and the side that is across from the right angle is always the hypotenuse. So this is an example of a right triangle, and we're going to need to know this information about where each of these sides is located in respect to this angle. So one thing that you may be familiar with is a phrase called SOHCAHTOA. And basically, SOHCAHTOA is saying that if this is our angle theta, then sine is the opposite over the hypotenuse. So from this theta, this is the opposite, this is the hypotenuse. So if you were to put whatever this angle is over whatever this angle is, you would have this fraction. And then everything is as follows. Cosine is the adjacent over the hypotenuse, which is stated here, and then tangent is the opposite over the adjacent. And then of course, like we've discussed previously, if you know sine, cosine, and tangent, then you can easily take the reciprocal to find cosecant, secant, and cotangent as well. So let's take a look at an example here. So remember, SOHCAHTOA will be helpful. And it's always in respect to the angle theta, and theta is right here in this case. So if I want to find sine of theta, I will take the opposite over the hypotenuse. The opposite is 7, and the hypotenuse, again, is always across from the right angle. In this case, it's 25. I'm going to do the same type of thing for cosine. Cosine is the adjacent, which is 24, over the hypotenuse, which again is 25. If I want to find tangent of theta, I'm going to take the opposite angle, or opposite side, which is 7, over the adjacent, which is 24. And of course, since I know sine, cosine, and tangent, I can find the rest. Remember, sine and cosecant are reciprocals, so cosecant becomes 25/7. Cosine and secant are reciprocals, so secant of theta is 25/24. And then finally, tangent and cotangent are reciprocals, so cotangent is 24/7. Okay, so here is an example of applying SOHCAHTOA. Here is another type of problem you will see. It says first use the Pythagorean theorem to find the length of the missing side, and hopefully you notice that this here is the missing side. And then it says find the exact values of sine of theta and cosine of theta. Once we know all three side lengths, then we are able to apply SOHCAHTOA, like the previous example, and find any of the 6 trig functions. So I want to remind you that the Pythagorean theorem is, well, I guess typically it's a squared plus b squared is equal to c squared. C squared is always the hypotenuse, and it will always be the longest side. So since 4 is going to be the longest side, we can't just assume that this is a 3, 4, 5 triangle, because if x were equal to 5, then we would have a problem, because the hypotenuse is always the longest side. So let's go ahead and find this missing side. So we will have 3 squared plus x squared is equal to 4 squared, or 9 plus x squared is equal to 16. When I subtract 9 from both sides, I get x squared is equal to 7. So x is plus or minus root 7. We're always going to use a positive length when we are talking about triangles in this section. So this is going to be root 7. So now let's go ahead and answer the questions at hand. We want to find sine of theta. Remember, sine of theta is the opposite over the hypotenuse. So if theta is here, the opposite is root 7, and the hypotenuse is 4. So sine of theta is root 7 over 4. Then we also want to find cosine of theta. Cosine of theta is the adjacent, which is 3, over the hypotenuse, which is 4. So these are the answers to this particular question. Here we are dealing with a right triangle ABC, and it has legs of length 6 centimeters and 3 centimeters. Now it's important that you read this entire question, because it goes on and it specifically tells us where we want the 6 and the 3 to be located, because it will make a difference if 6 is here or here when we're finding sine, cosine, so on and so forth. So when we read on, we want to evaluate the 6 trig functions for angle B, where angle B is the larger of the acute angles. Okay, so let's say this is A, B, and C. Okay, now angle B is supposed to be the larger of the acute angles. Now you should remember from geometry that if angle B is larger than angle C, then the longer side is across from it. So if B is bigger than C, 6 goes here, and so 3 must go here. Obviously, my picture is not drawn to scale. Okay, so now we want to find the hypotenuse, which is this missing angle here. So we're going to apply the Pythagorean theorem. So if you want to pause the video and give this a try, that would be just fine. So the Pythagorean theorem will say 3 squared plus 6 squared is equal to, I'm going to call this x squared. 9 plus 36 is equal to x squared, or 45. So the square root of 45 is equal to x. So this is root 45. Now that I know all of these, I can go ahead and find the 6 trig functions. So we are just going to apply a little bit of SOHCAHTOA. And remember, you can only use SOHCAHTOA when you have a right triangle. Okay, and it's important to notice that we want to evaluate the 6 trig functions for angle B. So theta in this case is right here. So cosine of theta is the adjacent over the hypotenuse. When we rationalize the denominator, Oh, I suppose, I'm sorry, I was having a moment. This is fine, but if you want to reduce this radical, you certainly can. You can break this down into the square root of 9 times the square root of 5, or write it as 3 root 5. Sorry to go backwards a little bit. Either way is fine. If you do write it as 3 root 5, then things cancel, so it's a little bit nicer. So this becomes, after rationalizing, the square root of 5 over 5. Sorry about that. Sine of theta is the opposite over the hypotenuse. When you rationalize this, you end up with 2 root 5 over 5. Tangent of theta is the opposite over the hypotenuse, opposite over adjacent, which reduces to 2. Now we can go ahead and take the reciprocal of everything. So the reciprocal of cosine, this gives me the square root of 5. Cosecant of theta becomes square root of 5 over 2. And then cotangent of theta, the reciprocal of 2 is 1/2. So here are the answers to the 6 trig functions for angle B. Here is another example. It says, given an acute angle theta, if tangent of theta is 5/12, find secant of theta. Now there are a couple ways in which we can solve this, but what I'm going to do is use one of the Pythagorean identities in order to solve this. Remember from a previous lesson, one of the Pythagorean identities that we came across was tangent of theta squared plus 1 is equal to secant squared of theta. Now, we know that, let's see. We know tangent is positive in these two quadrants. And if we are talking about an acute angle theta, that means we are in the first quadrant. And in the first quadrant, secant is positive because both sine and cosine are positive there. So of course the reciprocal will also be positive. So when all is said and done, I need to make sure that my answer is positive. Well, we know what tangent of theta is, so I'm just going to plug that in here. So I have 5/12 squared plus 1 is equal to secant squared. Now, since this is division, I can square each of these. So I have 25 over 144 plus 1 is equal to secant squared. Now, it may be helpful to think of 1 as 144 over 144 because that simplifies to 1. But if I'm adding fractions, I want to have the same denominator. So when I add those, 25 and 144 give me 169 divided by 144. And again, I'm just adding these to get secant squared. Now I need to eliminate the square by taking the square root of both sides. Don't forget the plus or minus. Remember, when you square root a fraction, you can take the square root of the top number and the square root of the bottom number separately. So this gives me plus or minus 13/12 is equal to secant. We just spoke about how secant must be positive in the first quadrant. So I can go ahead and conclude this by saying secant of theta is 13/12 in this case. This problem is very similar to the previous problem, so you may want to pause the video and give this a try on your own. Here, we're told that sine of theta is 3/4 for the acute angle theta. We know that sine is positive here and here. But if this is my initial side and I rotate in this direction, I know that I must be dealing with an angle in the first quadrant if theta is in fact an acute angle. So again, in the first quadrant, everything is positive. So our final answer, again, must be positive. So let's go ahead and sketch a picture of this. Here is theta. If this is theta, I'm interested, or I know rather, that if I have a right triangle, I can think of SOHCAHTOA. And if I'm given sine, then this is the opposite, and this is the hypotenuse. So here, the opposite is 3, and the hypotenuse is 4. So I must find this angle here, and I can do so by applying the Pythagorean theorem, because it is a right triangle. So x squared plus 3 squared is equal to 4 squared. X squared plus 9 is equal to 16. Subtract 9 from both sides, and x squared is equal to 7. So x is plus or minus 7, but in the first quadrant, I know I should have a positive value. So this is a positive root 7. Now we are asked to find secant of theta. So if I can find cosine of theta, I can find secant of theta. I know that cosine of theta is the adjacent over the hypotenuse. So that means secant of theta is the reciprocal of this, which would be the hypotenuse over the adjacent. So in this case, the hypotenuse is 4. The adjacent is root 7. So when I rationalize this denominator, I end up getting 4 root 7 over 7. It's positive. I'm happy. Here we have an example of an isosceles right triangle. And when we have an isosceles right triangle, we know that the legs are congruent. Here we have a right triangle that is a 30, 60, 90 triangle, and we have these sides here. One way you can think of this is by applying SOHCAHTOA to each of these angles. Specifically, if I'm interested in sine and cosine, in this first box here, cosine of 30, that would be with respect to this angle. If I want sine of 30, I'm interested in the opposite over the hypotenuse. So this is 1/2. With respect to 30, if I want the cosine value, cosine is the adjacent over the hypotenuse, which is root 3 over 2. Here, we are basically identifying the values of our special angles again. But instead of using the unit circle like we did previously, now we are applying right triangles. The rest of this chart can be filled out using the exact same process of SOHCAHTOA. You should know these as is. Okay. On this slide here, it basically gives you all of the trig functions of the special angles. Quite honestly, if I were you, I would somehow memorize as much of this as possible. But remember, if you know sine, cosine, and tangent, you can easily come up with the other 3 trig functions. Remember also that 30 degrees is equivalent to pi over 6, 45 degrees is equivalent to pi over 4, and 60 degrees is equivalent to pi over 3. The way I remember this is 6 and 30 and 3 and 60, they're kind of opposite, so that's how I remember that. Now, there are a couple others that I would recommend memorizing that come up a lot, and that is tangent of 30 degrees and tangent of 60 degrees. Think of it this way. Tangent of 30 degrees is the same thing as tangent of pi over 6, right? Because we just said 30 degrees and pi over 6 are equivalent. One's just in degrees, the other's in radians. This is equal to the square root of 3 over 3. Just memorize it. On the other hand, tangent of 60 degrees is the same thing as tangent of pi over 3. We talked about 60 degrees and pi over 3 right here. This is equivalent to the square root of 3. Now, both of these involve some form of square root of 3. Here's how I tell my students to remember it. 60 degrees is a larger angle than 30 degrees. The square root of 3 is a larger number than the square root of 3 divided by 3. So that's how I would recommend memorizing this. All of this is going to come up in future math classes, so if you just spare yourself, I would memorize it now so that it doesn't become an issue as you move on. Okay, so let's use the information that we found on the previous slide and answer these questions. We want to find the exact value without the use of a calculator. So, tangent of pi over 3, we just talked about that. Remember, tangent of pi over 3 is equivalent to tangent of 60 degrees. 60 degrees is bigger than 30 degrees, so this result is root 3. The square root of 4 over 4, pi over 4, remember that corresponding ordered pair is root 2 over 2, root 2 over 2. So secant is the reciprocal of that. So if I have, so this is root 3 minus. So if I have secant of pi over 4, that's 2 over root 2. But if I rationalize this, I end up just getting root 2. So the exact value that we are interested in is root 3 minus root 2. These are not like terms, so I cannot combine them, so this is the final answer. 30 degrees is equivalent to pi over 6. Remember, pi over 6 has the corresponding ordered pair root 3 over 2, 1/2. This should be coming a little more clear to you from our previous lesson. Cosecant is the reciprocal of sine. Sine of pi over 6, or 30 degrees, is 1/2. The reciprocal then is 2. Sine of 45, we already figured that out in the previous example. It's the square root of 2 over 2. We're multiplying this by 2, so we can cancel those out, and this reduces to 2 minus the square root of 2. And that is the exact value without the use of a calculator. Now we're just going to be practicing a whole bunch of these, so it may be helpful to pause the video and give this a try on your own. So each of these have an angle of 45 degrees. So if I'm working through this problem, I will think of pi over 4 radians. When you move on to calculus, calculus uses only radians, no degrees. So that's why I utilize radians much more than degrees, because I'm trying to prep you for upcoming classes. Pi over 4 has the corresponding ordered pair of root 2 over 2, root 2 over 2. So if I know this, then I know cosine and I know sine, so I can find any of the trig functions. Cosecant of 45 degrees is the reciprocal of sine, which is 2 over root 2. When I rationalize this denominator, I get 2 root 2 over 2, and that becomes the square root of 2. Secant of 45 degrees is the exact same thing. And then finally, cotangent of 45 degrees. Some of you might know that right away, but remember cotangent is cosine of 45 degrees over sine of 45 degrees. The way I tell the difference between cotangent and tangent is that with cotangent, the co goes on top. Something to consider. This is root 2 over 2 over root 2 over 2, which is just 1. Not so bad. Okay, in this slide, we are dealing with 30 degrees. 30 degrees is equivalent to pi over 6, and pi over 6 has the corresponding ordered pair root 3 over 2, 1/2. Again, 3 times 2 is 6. So I can find each of these trig functions. Remember, the first is cosine, second is sine. So sine of 30 degrees is 1/2. Cosine of 30 degrees is root 3 over 2. And we just talked about memorizing tangent of 30 degrees. 30 degrees is smaller than 60 degrees, so this one is root 3 over 3. If you memorize things, this is a lot more manageable. Okay, so here we want to simplify some expressions. If I'm looking at this, I see that pi over 3 and pi over 6 are used quite a bit. So let's just jot down a couple notes real quick. I know that 30 degrees is equivalent to pi over 6, which has the corresponding ordered pair root 3 over 2, 1/2. Similarly, 60 degrees is equal to pi over 3, which has the corresponding ordered pair 1/2 root 3 over 2. This is all the information that I'm going to need to answer both of these questions. So in part A, if I want cotangent of 60 degrees, I want cosine of 60 over sine of 60. This, the 2's cancel, and I'm left with 1 over root 3, which is equivalent to root 3 over 3. Cotangent of 30 degrees is root 3 over 2, 1/2. The 2's cancel, and I'm left with the square root of 3. So I have root 3 over 3 minus root 3. If I want, I can write this as 3 root 3 over 3 because the 3's would cancel. So if I have root 3 over 3 minus 3 root 3 over 3, I end up with a negative 2 root 3 over 3 for a final answer. I'm going to do the same type of thing in part B. So first, sine of pi over 3. Sine of pi over 3 is root 3 over 2. Cosine of pi over 6 is root 3 over 2. Oops, I'm sorry. Plus cosine of pi over 3 is 1/2. And sine of pi over 6 is also 1/2. Remember, with fractions, you multiply across the top and across the bottom. Root 3 times root 3 is 3 over 4 plus 1/4. 3/4 plus 1/4 is 4/4, which is equivalent to 1. Here, I just want to emphasize the importance of these reciprocal and quotient identities. We've talked about this quite a bit before. Make sure you know those. Likewise, make sure you know the Pythagorean identities. We've talked about those previously. We use them again today. They will come up a lot. Now here we have cofunction identities. And cofunctions basically means the following. If I'm talking about sine and cosine, cosine means the complement of sine. And you should remember from previous lessons that the complement or complementary angles add to be 90 degrees. So with that being said, sine of theta is equal to cosine of 90 minus theta, because these two angles have to add to be 90 degrees. Tangent and cotangent are cofunctions, and then secant and cosecant. So you can kind of analyze this a bit further if needed. I've provided a few examples of cofunctions here. If you notice, this plus this is equal to 90 degrees, and this plus this is equal to 90 degrees, or pi over 2. So what we want to do here is we want to use the fundamental identities to determine if the expression is true or false. If the statement is false, we're going to provide a counterexample. So basically what we're going to do is we're going to look at each of these trig functions, and we want to see if this whole thing simplifies to 1. If it simplifies to 1, the expression is true. If the left-hand side does not simplify to 1, it is false. So what I'm going to do is I'm just going to manipulate all of these and see what cancels out. Typically, I'm going to try to work with sine and cosine because those are a little bit easier to work with. So if I rewrite cosecant, I know it's the reciprocal of sine. So this is equivalent to 1 over sine of theta. Tangent, if I write that in terms of sine and cosine, this is sine of theta over cosine of theta. I'm going to leave this sine and cosine by itself. And this should all equal 1. Well, remember, if I'm multiplying fractions, I'm going to multiply across the top and across the bottom. And when I do on the top, I get sine squared of theta, because sine times sine is sine squared, times cosine of theta, all over on the bottom, sine squared of theta times cosine of theta. In this case, everything on the left-hand side cancels out. So I have 1 is equal to 1. This is a true statement, so we had a true expression. There's no need to provide a counterexample because this is true. Let's take a look at another example. Okay, so if you want, you can go ahead and pause this and see what you can come up with. Generally speaking, we try to write things in terms of sine and or cosine. So I want my left-hand side to become equivalent to the right-hand side if possible. Now looking at this, the only thing I can really do in order to rewrite this in terms of sine or cosine is to rewrite tangent. And I know tangent is equivalent to sine of theta over cosine of theta. I'm going to multiply this by cosine of theta. If this equals 1 minus cosine of theta, I'm done. But if it doesn't, we have a bit of a problem. Now, if I'm multiplying by the denominator, this cancels, and I'm left with sine of theta is equal to 1 minus cosine of theta. Now, if sine and cosine were squared, this is just another version of the Pythagorean identity. But they're not squared here, so I can see that sine of theta does not equal 1 minus cosine of theta. So this is a false statement. So what I need to do, if the statement is false, I need to provide a counterexample. So all I need to do is find some number for theta. I'm going to plug it in here to show that the left-hand side does not equal the right-hand side. So sometimes it might take a little bit of time to come up with a value that works, but let's just let theta in this case equal pi over 6. So this is going to be my work for my counterexample. So tangent of pi over 6 times cosine of pi over 6 is equal to 1 minus cosine of pi over 6. Okay, well, tangent of pi over 6 is root 3 over 3. Cosine of pi over 6 is root 3 over 2 is equal to 1 minus root 3 over 2. On the left-hand side, I can multiply across the top and across the bottom to get 3/6, which reduces to 1/2. Does 1/2 equal 1 minus root 3 over 2? No, it does not. Since these are not equal, I have just shown my counterexample illustrating that this is not a true statement. Here's an application problem involving right triangle trig. Students typically seem to like these problems. When you are solving these problems, first I would recommend that you sketch a little picture. So it says a 28-foot slide at a water park makes an angle of 60 degrees with the ground as it descends. So that is telling us that this angle here is 60 degrees. It says, what is the vertical distance from the top? From the top to the ground. Sorry, the slide is 28 feet, so this is 28. Okay, so we can see we have a right triangle. Now, we could find this missing side if we wanted, but we don't quite have all the information we need just yet. So what we should do is look at the things we do have. And we have this angle, 60 degrees. We have the hypotenuse, and we're interested in the angle opposite of 60 degrees. Well, since I have a right triangle, I can think of SOHCAHTOA here. And with respect to that 60 degrees, I'm interested in the opposite, and I have the hypotenuse, which means I could work with sine. Sine of 60 degrees is equivalent to the opposite over the hypotenuse. Well, all I need to do in this case is find x. So I can multiply both sides by 28. So I have 28 sine of 60 degrees is equal to x. Well, 60 degrees is one of our special angles. 60 degrees is equivalent to pi over 3, which has the corresponding ordered pair 1/2 root 3 over 2, which means sine of 60 degrees is root 3 over 2. 2 goes into 28 14 times, so x is equal to 14 root 3. This is measured in feet. I can multiply this out if I want. 14 times the square root of 3, I believe, is approximately 24 feet. And there you have it. Sometimes it's helpful to write your answer in a sentence. It says, what is the vertical distance from the top of the slide to the ground? You would say the vertical distance from the top of the slide to the ground is approximately 24 feet. Here is our last example. It's very similar to the previous problem, so you may want to pause this and give this a try. The only thing that might catch you off guard a little bit is angle of depression. And I want to remind you the following. If I'm dealing with the angle of depression, if this is the sky or the higher point, looking downward, this here is the angle of depression. So if we have an observer on the roof of a building, so he's or she is up here, an observer on the roof of a 40-foot building measures the angle of depression from the roof to the park bench. Okay, so the angle of depression then, so these are perpendicular here. So the angle of depression then is this, and it's 24 degrees. And here's the park bench. It's a fancy bench, you see. Okay, we can apply some rules of geometry that if these lines are parallel, alternate interior angles are congruent, which means this is also 24 degrees. And this is a right angle. We want to find the distance from the base of the building to the bench. So this is the length we want to find. So, like the previous problem, from here we have opposite and adjacent. The trig function that involves opposite and adjacent is tangent. So we are going to take tangent of the angle given, 24 degrees, is equal to the opposite over the adjacent. So this is what we need to find. So we can multiply both sides by x. So x times tangent of 24 degrees is equal to 40. But we want to find x, so we are going to divide by tangent of 24 degrees. Oops. So we're just going to plug this into our calculator. Since the angle measure is given to us in degrees, we want our calculator to be in degree mode. So you will take 40 divided by tangent of 24, and you should get approximately 89.84 degrees. Since we want to round to the nearest foot, this would be approximately 90 feet. This concludes the information from section 4.3.